predictor. However, which is not true for the unitary bands. Then we evaluated the degree of phase locking, just to give you an idea with how this is typically done. So the whole field in which you do this kind of statistics is called circular statistics. And what you could do, for example, to evaluate the locking strength is to calculate the average vector for each spike of unit length, and you enter it with its phase relationship, and then you can compute the average vector, and its length indicates a measure for strength, locking strength, or you can simply calculate the circular standard deviation of this period histogram to get the degree of phase locking. And when we looked at the statistics for this of the degrees of phase locking, what you see here is the circular standard deviation of the locking degree, and here is the measure when we pool all the spikes. And now we separated for the unitary bands and the chance coincidences and the isolated spikes. And if you look, for example, at this threshold, you see that the strongest locking, so the smallest standard deviation, is for the unitary bands and smaller for CC. Now, interestingly, if we look at the statistics for how many neurons are locked at all, it's about 38%. However, the distribution of occurrence of unitary bands in general and chance coincidences is very much the same in these two populations. So it's not trivially the case that only in periods or for neurons which occur in unitary bands see locking. But this seems to be distributed over all the population. In order to convince you that this locking is consistent across the whole population, we show here scatter plots of the degree of locking. For example, here again in cyan, chance coincidences versus ISO, unitary versus ISO, unitary versus CC. And what you typically can see is that the degree of locking is larger for unitary bands, so it's smaller as compared to the other comparisons, and this is distributed over the whole population. It's not a few which make it. Yeah. So, for example, if you compare unitary bands to isolated spikes, 84% of the unitary band locking measures are above or larger than the isolated spikes. Now we're also going to look on the contribution of the local field potential envelope. So in order to look at this, Michael did the following. He said, okay, I now apply a threshold onto the local field potential amplitude and call the spikes which are above this threshold, I call high spikes, and which are occurring below this threshold, I call low spikes. And then he looked at the locking degree of these two spike types. And what he found is if he is varying these thresholds so that he gets different, so to say, different selection criteria for high and low spikes, which is shown here, he observed that typically the high spikes, even if the threshold is already very, very high, show this locking. However, the low spikes have a much lower tendency to exhibit such a locking. So there seem to be two components. On the one hand, that high spikes have an increased locking to the local field potential. So this is, so to say, a summary where we have both components. On the one hand, this is a joint display where on this side we see for each spike or spike event, see the amplitude, and here the phase. So each spike is here entered at its corresponding position for its amplitude of the local field potential and the phase of occurrence. And this is separate again for ISO, CC and unitary events. And here you see the projections for the amplitude distribution of the three. And here you see again these phase locking histograms. And what you see is that the amplitude distributions of the LFP is typically, there is only very little difference of the three. However, the locking, again, as shown already before, but this is now for the whole population of data we analyzed, there is an enhanced locking for synchronous coincident events. However, only for unitary events this is exceeding the predictor. If we now, in addition, consider only high spikes, so do the same analysis only for the spikes above a threshold of 50% of the spikes. So this is, so to say, for this class the 50% level, for this class the 50% level, and so on. So if we do then only these analyses for these classes which are above this threshold, we notice that this locking degree of unitary events is even more enhanced. So it seems that this is a combination of, on the one hand, unitary events have a higher tendency to lock to the local field potential, and the spikes occurring at high amplitudes of the local field potential even more. So this is somehow interesting. However, we were extremely puzzled after having seen these results. And why should excess coincidences lock better than chance coincidences? Is there any reason for it? Yeah. And why do actually isolated spikes also show locking? If so to say, coincidences are, excess coincidences are an expression of assembly activity, why should then spikes, which show no indication of being involved in an assembly, also show a locking? Is this, so to say, consistent with the assembly hypothesis? Yeah? This was what we were asking ourselves at this point. And now I try to give you a simple model explanation which makes this picture consistent. Yeah?
One question. The isolated spike are isolated spike in the 4-electrode configuration, or is the simulation this? Because it's isolated in the experiment, but maybe it's grouped with the spike of another neuron.
Good point. Let me go on a little bit. Maybe this answers your question. Yeah. So we set up a very simple model, which should be already a little bit familiar to you, because it's again, so to say, with the idea of existence of synchronous activity, yeah, which you see here now.